Hello, and welcome to 5 Minute Math. Today we are looking at the 7th grade STAAR test 2025. My name is Aaron Doffer, and if you would like to follow along, I've created a custom statewide item analysis available that you can use using the tiny URL or the QR code on your screen. If you want to jump ahead to any particular item on this test, you can use these timestamps or you can use the bookmarks available at the bottom of the video. Our first problem is making predictions from simple experiments. This is 7.6H. Now, it looks like we've randomly surveyed 70 kids, and we're trying to find a true statement about the next 350 kids. So if we wanted to, we could multiply all of these by 5, and that would get us a pretty close estimate as to how many students would choose vanilla or chocolate or whatever. But we don't even necessarily need to do all of that. We can evaluate these statements just with our initial data and see how true they are. So let's replace each of these statements with an expression or an equation here. The number of children who selected vanilla, all right, 16, will be, so there's my equals, twice the number of children who selected strawberry. So 2 times 12. No, 16 is not 2 times 12, so that doesn't work. The number of children who select vanilla, okay, 16, will be twice the number of children who select orange sherbet. No, 2 plus 14, but not 2 times 14, so that's not working. The number of children who select chocolate, 28, will be twice the number of children who select orange sherbet. All right, that looks good. 28 equals 2 times 14. See, we don't even need to necessarily multiply these by 5 to get up to that 350. Let's check D. The number of children who select orange sherbet will be twice the number of children who select strawberry. All right, so it's not twice. You can say 2 plus 12, not necessarily 2 times 12. All right, so that was C as our answer. And we are starting with the first easiest item on the entire test. It starts out really easy. We had 78% of our students get this correct. So it's all downhill from here. Everything else gets more difficult. But that's a really soft one for us to start with, and that's typically how these tests work. The first few are typically on the easier side, and then they ramp up before usually ending with a few easy ones. Number 2, we are calculating unit rates. So this is 7.4b, and as you can see, we've got a drag and drop. Now we've got 4 different blanks here. So let's answer it, and then I'll tell you how the scoring works on this. All right, so a store sells 12 pairs of socks for 15. What is the price per pair? Okay, so this tells us right here. So price per and then pair. Well, let's put some numbers in there. The store sells 12 pairs for $15. So if we look at the question here, it gives us how to calculate that unit rate. We're going to divide the price by the number of pairs. And so first, before we actually calculate it, it wants us to actually tell you how to do it. Okay, so to calculate the price per pair of socks, we blank the number of blank by the blank. All right, well, we can only either divide or multiply. You notice that when I click this divide, you see how this is the only one that actually shows up as blue? I can't put it anywhere else. Same with multiply. So this first one has to either be divide or multiply. I'm going to divide. These numbers can fit, you see how they're blue here? The numbers can fit anywhere. All right, so let's divide the number blank by blank. What am I doing? I'm dividing 15 by 12. That's going to give me my unit rate. So 15 by 12. Now I actually have to calculate this. So 12 goes into 15 once. Let's add some decimals. You can also make this an improper fraction, try to solve it that way. That's going to be twice. 6, add another decimal. All right, so that's going to be 1.25. Or that's going to reduce to 5/4, which is 1 and 1/4, which we could then turn into 1.25. All right, so we've got 1.25. All right, so that is our answer. This is a 2-point problem. So if you get all 4 correct, that's the only way to get 2 points. and we had 42% of our students do that. If you get 3 or 2, so I'll say 2 to 3 correct, you get a half credit, 1 point. And we had 32% of our students get that. And then if you had 0 to 1 correct, you get nothing, 0 points. And we had 26% of our students get that. Now, what we do to calculate that percent correct, since there's 2 points, 1 point, we take half of our 1 point, because it's half credit, and add it up to there, and we end up getting 58%. Take your 16, add to the 42, we get 58% correct, which puts this definitely on the easier side. So this is tied for our 8th easiest item on the test. And this lets us know that when we are calculating unit rates, we need to not just do it, but give students the opportunity to describe or even write how to do it. Just this could even be a verbal conversation with someone you're sitting next to. Find the unit rate and then tell them how you did it. And if they can say, I divided this by this, then that's going to get them set up for this particular problem. And so this one uh, is 7.4b and 8th easiest, tied for the 8th easiest on the test. For number 3, we are looking at 7.2a. These are number sets. And so we've got this Venn diagram. And they don't tell us the labels on the actual diagram, but they do tell us the labels here. So let's go and label these. All right, so set K is rational. And then set L, integers. All right, so let's at least get those there. There's an error here. How do we correct this? Well, we can either look at each of these 4 answers, or we can just look. What do we know about, let's just look. What do we know about integers? Well, integers are whole numbers, and they're on both sides of 0, right? So -2, 2, right, and it goes on for infinity. So do I have whole numbers, not necessarily decimals or fractions? Yes, yes, yes. Okay, so there's no problem with set L. My problem is set K. Now, which of these is a problem? Well, let's take a look. A rational number is a number that can be shared as a fraction or a ratio. That's where we get that word rational. Think of ratio or fraction. All right, so they all look like fractions to me. So that means that one of these is kind of hiding out as an integer. So let's see if we can simplify this. 3/5 is already simplified. 7/4 is, if I want to make it a mixed number, 1 and 3/4, that's still fraction. But take a look at this. There's my sneaky integer. If you simplify that, 2 goes into 12 6 times. Really, that's a -6. When we were writing it as a fraction, because you write it as a fraction doesn't mean it needs to sit in that rational number square or rectangle. We need to bring that down here. So we need to move that -12 over 2 to set L because it is an integer. Even though we've written in fractional form, it simplifies to -6. And so our answer here is D. Take a look at our answer distribution here, right? We had 31. Choose it as the correct answer. That's hard. It ends up being the 6th hardest item on the test. So that was extremely difficult. But more students chose A than anything. And probably this is what they were thinking. They were, instead of thinking integers, right, they might have thought whole numbers. In whole numbers, we don't deal with negatives. We put those in integers. And they probably thought that that negative didn't make it an integer, and that goes back to labels. Inside this integers, we have another set, okay? And these are whole numbers, and it's just positive numbers. It's 0 to infinity with just positive numbers. The integers include that and then just go to the negative. So that's probably the mistake here. We had 18 go here, 15 go here. Overall, this was probably a lot of guessing. And so there was some students that probably chose D that just ended up guessing and getting it correct. But here's the misconception is that definition description of integers as opposed to whole numbers. And then even within whole numbers, we have a smaller set called natural numbers or counting numbers that include every whole number except for 0. Number 4, we are looking at 7.4a. And constant rates of change is what this problem is asking us to look at. And we have to evaluate constant rate of change. And you notice our answer selections are kind of split between equations and tables. So just like we did on the first one, right? Constant rate of change. How do we calculate this? Well, we want to look at the question. It's going to tell you the order. Which representation best describes the number of cycles, okay, in X hours, okay? So your cycles is Y in X hours, okay? So let's do cycles in hours, and then Y is going to equal that rate, that cycles over hours. Well, now since we have cycles in hours, and that's going to be our division line right there, let's just put some numbers there. I've got 90 over 2. All right, so that doesn't give me my unit rate. My unit rate has a denominator of 1, so we can simplify this. This is going to be 45 cycles per hour. So I might put CPH, that's cycles per hour. You can write it however you want to. There's our single rate. I need to represent that here. Now, I see a 45 here, but this looks like we flipped our independent and our dependent variable. We want it, our cycles in hours is Y. You notice that we've got that Y next to the 45. The X is the number of hours, right? So we need that to be flipped. So we wanted it to be Y equals 45X. X is our independent variable. We start here. We do something to it. In this case, we multiply it by 45, and we get our Y, our dependent variable. It doesn't work if you flip them. So A is incorrect. It's the right multiplier or coefficient, but it's just in the wrong place. B doesn't work because we're adding 45. I don't want to add 45. I want to multiply by 45. Therefore, it's going to have to be C or D. Now, look, they give it to us right there. Now, the 2 and 90 is not there, but if I figured out my unit rate, I've got my 145. It doesn't work here. So we can multiply 3 times 45 to verify that's going to get us 135. 5 times 45. That's going to get us 225. We're definitely multiplying by 45 here. This is our answer C. This was definitely on the easier side. We had 64% of our students get this correct. This was actually tied for our second easiest item on the test. So we always start out a little bit easier and then start to get difficult. We had 16% choose A, 15%. Not really many students fell for D. That 0 and 45 probably threw them off. For number 5, we're looking at volume. We have a triangular prism here. This is TEKS 7.9a, and it's pretty straightforward. What's the volume? Well, in case I forget, let's look at our reference material, see what we have for volume. Now, this is a prism, and so volume of a prism is base times height. Well, that doesn't tell us a whole lot because the hard part is getting that base. But we can at least put this down here. V equals base times height. Capital B, which means we need to find the area of this base. And what is our base? It is a triangle since it's a triangular prism. So let's go to the area of a triangle. This is 1/2 base times height. Okay, so our B equals 1/2 little b times height. That means it's just a single dimension here. That big B means it's actually the area of something. So if we want to, we can substitute this in for here. We can say volume equals 1/2 base times height, but that's kind of confusing because this height has to come from the triangular prism, and this height comes from the base. So we could do it either way. Let's just calculate this base times height and then multiply by 1/2 to get the area of this particular triangle base. We'll deal with that first. So this base is 1/2 times, right, that base right here. So that's the distance across the triangle. That's 10. And then the height. Since it's not a right triangle, we can't use this side, so they're going to give us this imaginary line that's going to be 12. And let's just multiply half of 10. That's 5 times 12. Okay, that equals 60. So this right here is 60 centimeters squared. Now, I just need to, I could put that right there if I want to. It's just this second height, but which number am I using? 20 or 13? Well, imagine you were standing this on its base. So imagine any prism and you stand it on its base. So there's going to be an equal base on the other side. So you can't really see it, but there's another base sitting back here, right? So here's your two bases. So if you're sitting this up on its base, right, it's going to end up kind of looking like this, right? So your height is going to be the line connecting the two bases. So this is what's connecting the two bases. This is unnecessary. That's just the side length of the triangle. We do not need that. And so we could do all this and multiply by 13 and get it wrong. Instead, we're going to say it is 60 times 20. So 6 times 2 is 12, and then I've got two zeros times 10, add the two zeros. I've got 1200, which is going to be D, 1200 cubic centimeters. Now, how did we do? Well, we had 36% of our students choose the correct answer. We had 34, almost the exact same amount. Take C, and we had some on A and B as well. What was so enticing about this? Well, you notice that 2400 is twice the amount of 1200. So how do you get 2400? You don't take the 1/2. It's this 1/2 right here that a lot of students miss. They just did base times height, 10 times 12 times the other height. 10 times 12 times 20, boom, they got 2400. And that's a lot. That's a lot of students that miss that. So when we are doing the volume of a prism, I do suggest we look at it in two chunks. We look at it first, let's figure out what is the base, calculate that separately, and make sure we're doing it correct because the triangular base is definitely, involves three things or a half, a base, and height. Then when we do that, then we find the volume by multiplying that by the height. This was definitely on the harder side. This was the ninth hardest or tied for the ninth hardest item on the test. So definitely a challenge for us. Number 6, we are making predictions using theoretical probability. This is 7.6D. And as you can tell, this is going to be a two-part problem. And we have different drop downs that we need to fill in. And so we have a spinner here that is divided into 10 sections of equal size. That's important so we can do some fractions here. And then we spin this arrow 150 times. All right, so we just spin it 150 times. We're going to make some predictions. The arrow will land on 20 about, let's take a look at what our answers need to be. About how many times? Okay, well, let's see. How many total sections we have? We've got 10. How many sections are 20? One, one time. Okay, so my probability of landing on a 20 is 1 out of 10. And I need to spin it 150 times. So I'm going to make a proportion here. I could do some cross multiplication, or I could just say, you know what? These are equivalent fractions. I need to multiply by 15. So if I multiply that by 15, well then, I'm expecting it to be 15 out of 150 times. So let's do that. Now the arrow will land on 0 or 5, and then I'm just doing another proportion. So let's look at 0 or 5. I've got 1, 2, 3, 4, 5. All right, so 5 out of 10. Now, before I do some calculations, I can go ahead and simplify that to, that's half, right? And so I need to make a proportion there out of 150, right? I can multiply that by 75, which means I'm multiplying that by 75. So half of 150 is going to be 75 times. And that's all we're needing to do here. This is a 2-point problem, and yet we only had 33% of our students get both points, 34 at 1 point, and then 33 get 0 points. So that's about 50% overall percent complete. if you take half of the 1 points and add it to the 2 points. So that was right in the middle of the test. There's 38 items on this test, so this is the 19th, and then depending on which way you count, the hardest or the easiest. Hide. And so this was kind of right in the middle of the pack, and it shouldn't have been super difficult. 150 is a fairly easy number to work with when we're setting up proportions. Hopefully at this point, students are used to making predictions using proportions. So we're just trying to get from 10 to 150. That's a times 15, but even then, we're multiplying it by 1 or we're multiplying it by 5 if we didn't simplify. So that's not too difficult. I think the big thing here is recognizing that we do need to set up a proportion, because if we can do that, well, now we know what to do. For number 7, we are solving rate problems. This is 7.4D, and we've got a basic setup here. We've got a student being paid $12 per hour, and then the pay increases to 15% increase. All right, so this particular standard 7.4D, it requires us to solve different types of rate problems, but it says including percentage increase or decrease. So we always need to make sure that we're ready for these problems. All right, so how do we find a percent increase or decrease? What we do is we take the difference with the increase or decrease, and then we divide that by the original amount. And that's just the one thing that you're not going to see on any particular reference material or anything. So students need to come into the test knowing this. So what's the difference between 15 and 12? Well, let's just kind of load it up like this. So 15 over 12 is going to be 3 over 12. So that's going to simplify to 1/4, which makes 25%, which if we think about it, makes sense. I've got my 12 bucks, right? And if we break it up into 4 parts, 25% each, that's going to be 3, 6, 9, 12. So I increased by $3, which is 1 out of 4 parts. So that's where that 25% comes from. So our answer here is C. And we only had 33% of our students choose this. Now take a look at the answer selections. You can probably guess which of these actually had more people choosing it. If you chose A, you are correct. We had 35% of our students choose A. That's more than chose the correct answer. And it's literally, they think that the 15 minus 12, you get your 3. It rose $3, therefore $3 is 3%. Not unless the original is 100. If the original is 100, then you could just move it up 3%. Other than that, you have to do that second step. The first step, obviously, we could do mentally, but then we had to divide that by the original to get the percent increase, and that just takes practice. This ended up being tied for our 7th most difficult item on the test, and students need explicit instruction and practice with percent increase and decrease because it is called out in the standard. Number 8, we are looking at the circumference and area of circles. This is 7.9b. And we have a circular sign, has a diameter. All right, so I'm going to draw a circle. I need to know that my diameter is all the way across. That's 20 inches. And so I need to determine the measurements that are closest. All right, you notice that we're approximating here. There's no decimals here. So what is my area? What is my circumference? Well, in case we forget, we have the reference materials. So my circumference is 2 pi r, or pi times diameter. Since they give me the diameter, let's just do that. Circumference equals pi times diameter. And then my area is, I will need my radius on that, pi r squared. All right, so circumference, let's do that second one first. It's pi, which is approximately 3.14, right? We have that on our reference materials in case we need that, approximately 3.14. And we're going to multiply that by our circumference, which is or our diameter, which is 20. All right, so let's think about this. We could go ahead and think of multiplying this by 2. So if we just double this 3.14, that's going to be 6.28. That gets us multiplied by 2. And then we're not multiplying it by 2, we're multiplying it by 20. So we need to move the decimal over 1 because when you multiply by 10, everything gets shifted a place value to the left. So it looks like 62.8. I don't have a 62.8, but I do have that 63, so we can go ahead and just bring that right there. It's our approximation. We need to find the area that's closest. Now I need to find the area of the sign, so that means I need the radius. Now the radius is going to be half of the diameter, so that's going to be 10, because 10 plus 10 makes 20. So it's going to be pi times 10 squared, or pi times 100. Well, if my pi is 3.14, and if I multiply by 100, I move the decimal over twice because everything gets shifted over 2 times to the left, then I can just call that 314. I could do that mentally. And I do have that answer here, 314. So that is my area and circumference. That is a 2-point problem. Take a look at this. 21% of our students got 2 points. We had 36% of our students get 1 point, which means we had 43% of our students get 0 points. They couldn't even get this, pi times diameter. If we are assuming that it's difficult to get the radius from a diameter, which it's not, I understand where maybe this takes a little bit of extra work, but how are our students, 43% of our students, unable to use this particular formula, which is given to us on the reference material? We just need a lot more experience. Perhaps not having the actual decimals might have messed them up, though, getting 62.8 obviously is going to be that close to that 63, but we need to provide our students additional opportunities to estimate, right? So maybe they estimated pi as 3 and they just multiplied by 20. Well, if you do that, you're going to get 60. So 63 is still the closest. And if you were to do the same thing with your pi of 3 and then multiplying that by the radius squared, you would get 300, which 314 is still the closest. There's not anything that's super close to that. So you would still get that either way, but overall our percent correct is about 39%. So this is definitely on the harder side. And this is actually the 12th hardest item on the test. Number 9, we are looking at slope-intercept form. This is 7.7a. And we are taking a verbal description here, and they give us an equation, and then we need to just put that into context here. So what do we have? Kenny spends the same amount of money from his bank each week. So spends means we're taking money away. That's why we have a negative 35. Looks like he's spending 35 per week because X is the number of weeks. And then the equation shows Y, the amount of money Kenny's bank account has of the number of weeks. Okay, so this is your money. We're spending 35 a week. What is this 500? Well, if you're spending 35 bucks a week, you must have some money in there. So this is going to be your starting amount. If you can't spend money you don't have, so you have to start with something. In that case, you start with a fixed amount, 500 bucks, and we're spending 35 bucks a week. All right, so we want a beginning balance of 500, so these two are good. These two aren't going to work. And then spending minus, that's going to give us decrease. We just need to know that that means decrease rather than increase. And so our answer is A. We did not do that difficult or do not do that poorly on that. 63% of our students chose that. Another 17 chose B, and they at least got the starting amount. They just, messed up the increase rather than the decrease, but at least they got that starting amount. So that's 80% of our students that chose A or B. But ultimately, this was fairly easy. In fact, this was tied for our second easiest item on the test. And so Uh, Good job, students, for not necessarily being fooled by any of that or being tripped up by just the large volume of words. Number 10, we are solving scale problems. This is 7.5C, and it's a hot spot. It looks a little bit like what is happening here, but it's just a map of Texas. We just need to select one of these cities here. And so what we have is information saying that Layla lives in Austin. Okay, so everything starts in Austin. And Layla is going to visit 146 miles in a certain direction. And we've got this scale given here, but it's not necessarily given on the map. So this is the key here. 0.5 inch equals 25 miles. All right, we don't necessarily need a ruler because they give us inches here. Okay, so let's set this up as a proportion. I've got 0.5 inches over 25 miles equals, I need something that's 146 miles away. So I'm going to make miles go with miles. Right, they're always across from each other. You can make miles over miles if you want to. That will give you the same answer. And then I'm needing something, I need the inches. All right, so I'm needing to know which of these inches makes the most sense. All right, rather than getting into super decimals, what I'm going to do is I'm just going to use compatible numbers. And I'm thinking 25, 50, 75, 100, 125, 150. If I just make that 150, then I just need to multiply this by 6. And that's going to be a lot easier than doing, I mean, I could do the cross multiplication and whatnot, but that's going to get me, a technical decimal answer. Let's see if we can make this easier. If I round up to 150 and use that compatible number, I can multiply 25 by 6, which means I'm going to multiply that 0.5 times 6, which is going to get me 3 inches. Now, I rounded up, so it's going to be just a little bit less than 3 inches. And we see here that Houston is just a little bit less than 3 inches. And so Houston is going to be our answer. And we had just 41% of our students get 1 point. This is just a 1 point problem. And 59% of our students not be able to get that. We do not have data as to which of the other choices were selected. But this was a unique scale problem simply because the setup involved a map, and typically it's all just words. So this map might have thrown us off. And there's a possibility that these inches are not the easiest to read. We need to know that this goes with this line. The 5.9 goes with this line. The 2.9 goes with the line we want. And then we need to know that 1.9 goes here, and then the 3.46 goes here. So that could have taken a little bit time for our students to kind of, figure out, and they could have honestly tripped some of us up because they were kind of packed together. This was just slightly on the harder side, 14th hardest item on the test. Number 11, we are looking at operational word problems. Typically is what we do with 7.3b, but there's no word problem here. It's just operations. Usually when we see this standard, it's embedded in a word problem, but let's just see if this makes it any easier. If we are just doing an operation without necessarily any context. So there's really two things happening here. First off, we've got negatives, but I am going to subtract. I've got this. Let's deal with that first. Negative 4 and 2/5 multiplied by 6. I've got a negative 0.8, but we'll do that right there. All right, so I've got a decimal and a fraction. I'm going to go ahead and just make everything a decimal since my 0.8 is already a decimal. Multiplying is going to be a lot easier if I make everything a decimal. So let's change my my 4 and 2/5 into 4, and then if I double the top and bottom, I'm going to get 4/10. So I can make that 4.4 because that's 4/10. Multiply this by 6. All right, so here we go. Let's just take my 4.4. Let's multiply that by 6. I'm just going to do standard algorithm here. 24, it's 24, 26. It's negative. All right, so I've got negative 0.8 minus 26.4. I can think that as a plus negative 26.4. And so when I'm subtracting a negative from a negative, it's actually just going to work like addition. You're just going to add these two negatives together to make a larger negative. So it's going to be 12, 7, and then that's 2. So negative 27.2, right? Because if we think if there's my 0, I've got my negative 0.8, and I'm going to make this big jump over here, negative 26.4. Then I'm going to get farther away from 0. In fact, it's going to be 27.2, and our answer here is D. Now, this one, just take a look at the answer distribution here. I had 27% choose D, 26% choose A, 25% choose B, 21% choose C. This is guessing. Students were tripped up by multiple things. Now, there are multiple things that could have messed this up. First, students needed to be able to generate an equivalent decimal for this negative 4 and 2/5. And so if they couldn't do that, they might have gotten tripped up by multiplying a whole number by a mixed number, which you could. You can multiply 6 by 4 and 2/5. You would just need to kind of break it apart, use the distributive property, multiply 6 by negative 4, multiply 6 by that negative 2/5, then add those two results. But it's a lot easier to just change from this to this. I don't think that's much of a challenge to do the 4.4 times 6, but I do think negative 6 or negative zero point 0.8 minus negative 26.4, that also might have tripped students up. Subtracting a negative from a negative, getting a larger negative, that still, it's a new concept in 6th grade, so it still could be a little bit confusing for 7th grade students. And so I definitely understand how that could have tripped them up. To put all that together, that makes this tied for our third most difficult item on the test. And there's no word problem to try to understand. It's just straight operations. So this is one, teachers, we can circle this and we can have some additional practice on problems like this. Number 12, we are looking at the area of composite figures. And so we've got just it's going to be an equation editor here. We're just going to type in our answer. So let's take a look to see what we have. Now, it might look like we're missing some information, but the information is actually given to us in the stem. Two congruent right triangles. We need to know that congruent means they are equal. So if I have the dimensions of one of these right triangles, I automatically have the dimension of the other right triangle. I mean, this rectangle is easy. 7 times 6 is 42. We're not even going to stress about that. The challenge here is to figure out these right triangles, okay? So we need a base and a height. Well, this base goes with this base. So we'll say that's 6, right? They're both the same side of a rectangle. And then my height, well, if this side is 7, and then the whole thing is 10, that's going to make this 3. All right, so I have a right triangle uh, with attributes of 3 and 6. So I can do 1/2 base times height. So that's 1/2 6 times 3. So half of 6 is going to be 3. So 3 times 3, that's going to make this 9. So this is 9. And then I don't even need to do calculations for the other one because they're two congruent right triangles, which means this is 9. So I have a 9, and a 42. So 9 and a 9 and a 42. That's 18, that's 20, that's 60. So we have our area here of 60 centimeters squared. Now that is the correct answer. There's only 1 point, obviously, on this, and yet the fact that it is not a multiple choice always increases the difficulty. So if we can't double check our work, we just have to type it in blindly. Only 27% of our students were able to get this correct. And this is the third, or tied for the third hardest item on the test. So this is why when we practice area of composite figures or any problem in that, for that matter, in the classroom, don't have answer choices. Make the kids solve the problems themselves. That's why we like these problems from the math book, because that's going to most closely mimic their ability to solve a problem like this. Don't have them choose from A, B, C, or D. Don't even have them practice a drag and drop or an inline choice because those give answers to choose from. Spend most of your time with this type of problem where you're just typing in the answer or you're just having them write the answer on paper and pencil, and that's going to set them up for success in the long term. Number 13, we are looking at simple and compound probabilities. This is 7.6i, and we have these keychains here. We've got some frequencies, and we're asking, we got 5 colors, we're randomly selecting. We do it 40 times, and this is what we get. Now, we're looking at experimental probability. We cannot necessarily look at the theoretical probability because they never tell us how many actual reds, oranges, yellows, blues, and greens they have. Our thinking is it looks like there's more blues than any, and there's less yellows than any simply because that's what was pulled out. But that's the experimental probability showing. We could have the exact same number of each of these 5 colors, and the experiment just pulls out more blues than anything. So we're looking for the experimental probability here that the next keychain will be yellow or green. Okay, so what is yellow or green? Well, we've got 5 plus 8, so that's going to be 13 over how many times did we do it? We did it 40 times. Okay, so that means that there's a 13 out of 40 chance based on the experimental probability that we're going to get yellow or green. That's it. That's all that we need to do. We don't even need to simplify that. 13/40ths, fairly straightforward, and our students agreed they got 60% correct. Now, you can understand why we might have gotten 21% on C, because look, they're asking for 2 colors, yellow and green, over how many colors? 5 colors. That's not how probability work. We have to look at the experimental probability. Yes, there are 2 colors. This would work if all of these colors were equal. If there were the same number of red, orange, yellow, green, and blue, then it would have simplified to 2/5 theoretically. But not even if that was the case, we have to go with the experimental. So that's why we need to talk about the difference between experimental versus theoretical. And students will get this concept intuitively. They just might need a little bit of extra practice, just applying the correct term to experimental or theoretical probability. For number 14, we are describing pi. This is 7.5b. And even though there are 2 blanks here, this is a 1-point problem. We either get it right or we get it wrong. So we have a circular pool. So let's draw a circle here so we can always put something down as a representation as a radius. So we need to know that this radius means it's from the center over to a side, and that's 30 feet. And our circumference, all right, so that's going to be all the way around. Think of it like perimeter. Circumference equals 188.4 feet. All right, so we need to complete this sentence to best represent pi. Well, the value of pi is approximately blank divided by blank. Well, let's look at circumference and see what in the world that has to do with pi. All right, so circumference is right here, 2 pi r. Okay, so circumference equals 2 pi r, or we've got 2d, simply because double the radius, you get your diameter. Or, excuse me, that's going to be pi d. Let's get that right. Double the radius equals your diameter. So what are our options here? Well, if we wanted to find pi, how would we solve for pi? Well, let's use our properties of operations here. If I wanted to solve for pi, let me do it with this first one. 2 pi r. Well, if I divide both sides by what's connected to pi, since they're being multiplied by pi, what's that going to be? Well, if I divide by 2r, The 2's cancel and the r's cancel, so I'm just left with pi. So the division property of quality says I can do something to one side as long as I do it to the other side. So I would need to divide circumference by double pi or double r. And let's see if I did the same thing here. Divide by d. So I could do c divided by d equals pi. Now, this works because that equals that, right? Double the radius equals diameter. So basically, I need to take my circumference, right? So 188.4, and then divide that by the diameter, which is going to be an extra 30 feet here. Or you can just double radius to get 60. And so that's where the challenge is. I bet you a lot of students probably divided it by 30 rather than 60, but that is our correct answer. And only 24% of our students are able to get that correct. 76 missed one of the problems, and I'm guessing they probably divided by 30 rather than 60. So this was difficult. In fact, this was our second most difficult item. And typically, we will talk about pi as circumference divided by diameter, but this drag and drop made it a little bit more challenging, and the fact that it's written out in words as opposed to just an equation also made it challenging for students. Number 15, we are solving graphs. This is 7.6G. So we have a plot here, and we need to evaluate each of these statements. So let's put some numbers on this dot plot. I've got 2 that scored 0, 1 that scored 2, 6 that scored 3, 2, 3, and 1. So if we add all this up, we're going to get 15 total. So we're going to need that because we're going to basically be evaluating a whole bunch of fractions and percents here. So we're looking for the one that does not ring true, that is not supported by the information. So that means 3 of these are going to be true. We want to eliminate those. So let's start with exactly 20% of the players scored 6 points. How many students or players scored 6? That's going to be 3. And 15 is our total. So if we simplify this, right, we're going to simplify by 3's. We're going to get 1/5, which equals 20%, which is what they say, which means it's true, and we don't want it. We're looking for something that's false. 40% scored 3 points. Well, that's 6. Now, I'm going to do it like this, but another way to do this would be to simply say, well, 3 is half of 6, so if I double 3, I'm going to get 6. So if I double my 20, I'm going to get 40. So you could have just used what you learned on the 3 over 15, doubled it to get 6 over 15. You would get the same answer. That is correct, which means we don't want it. Now, less than a third scored 4 points. Okay, well, how many players scored 4 points? That's 2. So I'm saying my 4 points is less than 1/3. Well, those are different denominators. Let me make this into 15ths, right? Since that is 2/15ths, I could make this 5/15ths. So now we're saying 2/15ths, the 2 that scored 4 points, is less than a third, which is the same as 5/15ths. That's true, which means we don't want it. So we're down to D. More than 1/10 of the players scored 8 points. How many scored 8 points? 1/15th. We're saying this is greater than or more than 1/10. Now, I don't need to have like denominators here because even back in third grade, we looked at comparing fractions with either the same numerator or the same denominator. In this case, the same numerator. So I'm looking at 15 and 10. So 15 is larger than 10, correct, but when it's in the denominator, that means the pieces are smaller. Imagine taking a pie and cutting it into 100 pieces, how tiny those slivers are, and then taking that same pie and cutting it into 3 pieces. Those pieces are going to be huge compared to the hundredths. So as the number gets larger in the denominator, the piece gets smaller and smaller and smaller. Therefore, I cannot say that 1/15th is greater than 1/10 because the 15ths are smaller than tenths. In fact, that's going to be incorrect. And so that's the one we want, D. And we had only 36% of our students choose this. Now we had pretty fairly distribution of other answers, which means we're getting pretty close to just thinking a lot of students guessed on this one. And so this one was difficult. You notice how to turn each of these fractions into percent in order to evaluate. But, some students might not have seen this, right? 3 points is 6. They might have not have taken it over 15. They might have taken it over 10 for whatever reason. And they might have, thought that was incorrect. And so 4 points, right? Two, look at how many people we have. We have two. Two is less than, you know, one, or two is greater than one. So they might have think, well, okay, so two is greater than one, but that's not how it is because it's not two, it's 2 over 15. There are ways to get B and C, but you really have to kind of twist yourselves into knots to make some of those challenges or some of those misconceptions make sense. So this was tied for our ninth most difficult. This was just a lot of work. This is potentially 4 times as much work as any other problem because basically you have to do 4 separate math problems, A, B, C, and D, and then evaluate each of them. And then sometimes our students just run out of stamina. So this definitely needs a little bit of extra practice. For number 16, we are looking at equations and inequalities. This is 7.11a. And we have Arnold. He can spend no more than 450. Okay, so I'm just going to put this right here. If he can spend no more than, I'm going to build it like this. Whatever he does has got to be less than or equal to 450. So that's how I'm building it. I'm going to build it left to right. Um, if you want, you could build it the other way. You could say 450 is greater than or equal to, whichever way makes sense to you. But let's just start building this. He can spend no more than 450 bucks. Okay, it's going to be 150 bucks to rent the theater, and then the food is going to cost 12 per guest. Okay, so it's going to be like slope-intercept form, except we've got an inequality here. So 12 bucks per guest. 12 is my unit rate. All right. So let's do this. Let's use the properties of equality. Let's get rid of this 150. We're going to subtract from both sides. And so I've got 12x less than or equal to, now I'm sitting at 300. I'm going to divide both sides by x or by 12. 12 is a positive number, which means I don't have to worry about changing the inequality. So it's just going to be x is less than or equal to, and that's going to be 25. So if we want to double check this, we can say, okay, 25 guests, 12 bucks each. Let's put that there. That's 300 bucks. And then you add your 150 back in to rent the theater. All right, that works. So less than or equal to 25. Our answer here is D. We only had 37% of our students get this. Now, 28% chose C, which I can understand. They did the work, they just missed the inequality. So you notice the very first thing I did was when I saw this no more than 450, I immediately interpreted that to be this, right? So, because that's going to obviously change the answer if I do all the work and then I've got the wrong inequality. And then some students kind of got messed up here. What ends up happening here is 150 plus 12x in order to get rid of that 150. Sometimes people will just add 150 instead of subtracting 150. Then you get 12x is less than or equal to 600, which ends up with this right here. You could do the same thing with A, but then obviously we've got both the operation was wrong and the inequality was wrong. This was the 11th most challenging item on the test. So sometimes we need to just set up the inequality. Sometimes we need to go all the way through and solve it. And this is one of those opportunities that we needed to solve it. Number 17, we are comparing numeric data. And so this is 7.12a. We've got box plots, right? So we always need to have two pieces of data, so two graphs, two data sets, something here. And then we're just going to compare when we're looking at the standard. So we should never do this with just one graph because you can't compare anything with just one graph. You need at least two. And we're going to need to do a whole bunch of calculations, and then we need to find which one is true. Like the one just a few problems ago, that was which one was false with the dot plot. All right, so the range, all right, so range is the difference between the greatest and the least. So let's find the range for group 1, 12 and 28. Okay, so group 1, 28 minus 12, 16. Group 2, kind of in between, but that's fine. They're just an interval of 2, so that's going to be 15. So that's going to be 33 minus 15. That's 18. All right, so I've got the ranges so far. So the range of the data for group 2, 18, is equal to the range of the data for group 1, 16. That is false. Secondly, the distribution of the data for group 1 is more symmetrical than the distribution of data. All right, symmetrical means how much of a reflection is it? Is it equal? Okay. Well, if we look at group 1 is more symmetrical, let's take a look. Look at the distance between these two quartiles right here. So that's a distance of 4. Look at the distance between these two quartiles, 24 and 28, 4. Look at the distance here between the second and, or its first and the second quartile. That's a distance of 4. And look at here, 4. It's literally symmetrical. That is the definition, the textbook definition of a symmetrical data set, because everything is 4 away. Whereas look at the difference here. This is from 15 to 21, so that's 5. But look at over here, I've got 3. And this has got 21, 26, that's 5. And then that is 4. So this is skewed to the right because it's larger on the right than it is, or on the left than it is to the right. And so the distribution of the data for group 1 is more symmetrical. Yeah, that's true. Group 1 is very symmetrical. Group 2 is, it's not horrible, but it's not exactly like a reflection. That means I'm looking for C and D to be both incorrect. So let's verify that. The interquartile range. All right, IQR, colors here, is kind of like range, but we're looking at quartile 1, quartile 3. So the IQR for group 1, let's just do this. I've got 24 and 16. That shows you the measure of spread, but within the middle 50%. That's 8. And then group 2, it's going to be 30 and 21. All right, so this says the interquartile range for group 1, 8, greater than group 2, 9, false. And then the median, all right, the median is actually pretty easy when you're looking at a box plot because it's quartile 2, which is right there. So group 1 is 20, is greater than group 2, 26, false. All right, so our answer here is going to be B. And this one was on the easier side. We have 55% of our students able to get this. We had 12, we had 24, we had 9. So obviously, our biggest distractor here is 24. And we just possibly reverse the comparison. Maybe we just tried to eyeball it. But something was really kind of, you know, bringing students into thinking this could be the correct answer. Maybe we're not 100% sure what the interquartile range is. So we are just looking at the ranges. But even if you're just looking at the ranges, remember the range is 16 for group 1 and 18 for group 2, so that's not it. So this might have been just a guess if we're not quite sure. This was on the easier side. In fact, this was tied for our 11th easiest item on the test. For number 18, we are looking at equations for geometry concepts. And this is 7.11c, and we have an isosceles triangle. And so let's at least draw that. And so we've got an isosceles triangle, and we'll just kind of make it look like this. All right, we say we have one angle that's 50. Now, with an isosceles, we know that two angles and two sides are the same. So I don't know whether this is the other angle or if this is one of the two base angles. Here we go. Each of the other angles is x. All right, so each of the other angles means there's going to be two other angles, which means that's got to be x, and that's got to be x. And so now I've got my 50 up here. All right, so now I've got my three angles, 50, x, and x. So basically what this is telling me is 50 plus x, or we can say 2x equals. Now, I need to know how many angles are in any triangle and the interior angles. And that's not on my reference materials, but that's 180. Learned that in 6th grade. So now I can just set up this algebraic equation and solve it algebraically. So I'm going to subtract 50 from both sides. My goal is to isolate that variable. So 2x is going to equal 130. Now I'm going to divide by 2. 2 divided by 2 makes 1, so that goes away. X equals, what is that, 65. Now, if we want, we can verify 65, 65, and then the 50 that was given. That's 10, and that's 3 sixes. That's 180. So our answer here is going to be A, 65. And we only had 40% of our students choose that one. Now take a look at the answer distribution. 18, 21, 21. These distractors, B, C, and D, were chosen by TEA for certain miscalculations or misconceptions that students might make, but that didn't necessarily seem to be the case. In this case, it looked like when they're that close, students are just guessing, which means only 40% of our students knew either that there were 180 degrees in a triangle. I'm probably thinking that that wasn't the unknown value. I'm thinking it's this setup here. We've got one angle at 50, and then we've only got one other number, and this each. You need to tie this each back into an isosceles to know that an isosceles has one angle that's the same and two angles that are the same and one angle that is different. And so it's that definition of an isosceles triangle that's probably going to be challenging for our students. And I would always suggest draw a picture. When you can, draw a picture. This ended up being on the harder side of the test, the 13th hardest item on the test. For number 19, we are making predictions from simple experiments. This is 7.6H. And so we've got this grocery store manager randomly surveying 100 customers. And then let's just evaluate each of these statements. All right, so we have 100 as our denominator. So that's going to be super, super easy. And then if we're going to do another 50, what would be the prediction? Well, let's just take these initial values, the 24, 16, 36, 24, and we can just see if these statements work for those values, okay? So customers will choose broccoli 1/4 of the time. Well, since this is over 100, right, I can go ahead and put these into percents if I want to. 24%, 16%, 36%, because percent means per 100, and they already told us there's 100 there. So broccoli is 16%. So what they're saying is 16% is or equals 1/4. Well, 1/4 is 25%. So that's not going to work. Potatoes would get close, but even then it's not exactly 1/4. All right, so B, customers will choose course 1.5 times as often as green beans. Okay, corn, 36, is 1.5, 1.5 times green beans. All right, so 24. All right, well, is corn 1.5 times as much as green beans? I don't know, I'm gonna have to multiply that. Let's see, 24, 1.5. That's going to be 20, that's 10, that's 12, that's 24. Look at that, 36. Yeah, that does work. Now, one thing we could do if you want to do that mentally is anything times 1 is itself. So that doesn't do anything. So multiplying something by 1.5, really, you're just going to change it by that 0.5. And so we could have taken half of 24, which is 12, and then added that to the 24 for the 1. 12 and 24 gets you 36. That's the way to do it mentally. So that looks good. Let's verify C and D are incorrect. The number of customers who choose potatoes is 24, will be equals 8 times those who choose broccoli. Nope. There'll be 8 more if this said 8 more, possibly, but even then, it only works if we were to do another 100. We're doing another 50, so you'd have to cut that in half. So, no, that's wrong multiple ways. The number of customers who choose corn, 36, will be 6 less than those who choose potatoes. Okay, so let's do 24 minus 6. No, that's just wrong on multiple counts. All right, so we only had 9% choose that one because that doesn't even remotely make sense. We had 45% of our students choose that, but take a look at our incorrect answers of C and A, 24 and 21. Right, so 24% of our students confuse this 6 more with 6 times, right? The 8 plus would have worked, not the 8 times. And then how do we get this 16% equals? Well, think about this. There's broccoli, right, is one option out of total options. How many total choices are there? 4. So I get how that works, but they weren't chosen at that exact same equal rate. But I could see how students might choose this. But as you can see, when we're evaluating this, what we need to do is we need to set up equations or sometimes inequalities, depending on the expression that they give us. And then we need to just solve it or evaluate it algebraically. And so this is on the harder side. This was the 16th hardest item on the test. And so this could potentially take 4 times as long as any other problem because really you're making 4 separate problems and having to solve each of them. And it's what is most difficult for students, the verbal description. Trying to take these as words and putting them into equations, that's difficult. And the only way to get through that is through just practice, practice, practice. Number 20, we are solving scale problems. We've got 2 quadrilaterals. Thankfully, one of them is not rotated, but sometimes we will get a rotation and that just makes things that much more difficult. This is 7.5c. And so we need to find the value of x. Okay, well, where is x? X is right here. All right, so x goes with, you see this, I'm going to make that line red. Okay, so that x lines up with a similar figure, right? And it said similar, which means they're going to have proportional sides and equal angles. In this case, we're looking for the sides. That goes with this QR. Now, there's quite a few ways I can set that up, but all we need to do is we need to make sure we're lining up the correct sides. So I'm just going to take this and I'm going to make those sides black, these sides blue, and then let's make these bottom sides green. All right, so those sides correspond with each other. All right, so we can set them up any way we want to. I'll show you a few different ways, right? So we can say, let's start with x over 7. All right, so I'm going to take the large side of x, or from the large shape of x, over the small corresponding side. So I need to do the same thing with, let's choose blues. Since my x is in the numerator and that's from the large shape, I need to take my large side of 36 over my small side of 4. Now, I don't have to necessarily do it like that, but let's just see what that looks like, and then I'll show you a different way. All right, so we're going to do a little cross multiplication. All right, so we're going to do 4x equals 36 times 7. What is 36 times 7? That is going to be 252. All right, so now I need to divide that by 4. 252, that is going to be 6, 24, and that's going to be 63. Okay, so it looks like I have a value here of 63, which I do see down here, but I see like A and B are totally different. So let's verify that a different way. I set up the red over red. You can also have a different way. So you still obviously need that X, but let me just set it up completely different. I'm going to use this 126, and I'm going to make that over my red X. I can set it up like this as long as I match that on the other side, which means I need the bottom on the small, 14, over the the matching one, like the slant on the small, which is going to be 7. Okay, so you notice how instead of the big over small like I had in this first one, I've got the big and the small across from each other. Either way, I'm going to need the X and the 7 either across from each other or over or under each other. But we're going to see here, we'll get the same thing here. So if you do 14x equals 126 times 7, that's 14, 18, 882. Now, we still have to do quite a bit of work to get that. So let's do 14 into 882. And that is going to be, I think it's going to be 6 because it needs to equal 63. So let's go ahead and just start with that, right? That's 84. And then that's going to be 42. And yep, 14 times 3 makes 42. So it does equal the same thing. So that's how proportions work. You can set it up multiple ways. Your answer is going to be D. And we had 55% of our students get that correct. So this is a little bit on the easier side. And we had 15 and 12. Now, here's the thing. I understand students might have done this if they took a look at this, and we need to literally find the value of x. We're not setting up a proportion. Every single one of these is a whole number. The smallest is 4, right? But the smallest over here on this big one is 36. So these two don't make any sense. If you just want to use reasoning there, it doesn't make any sense. And take a look at this x right here. All right, it needs to be a whole number. On the small one, it's almost double the 4, right? So the 7 is almost double the 4. Or you can take a look. Look at this 7 right here is exactly half of the bottom. So we could have done all this and say, well, if on the smaller shape, 7 is half of the 14, then I could have just taken half of my 126 and gotten 63. So we could have done this just by looking at the number sense. And sometimes some problems will allow you to do that. So this ended up being tied for our 11th easiest item on the test. 21, we are looking at slope-intercept form, and we've got probably the most basic setup. We have a line, and then we've got some drop downs here, but we need to just complete this slope-intercept form. This is 7.7a, and slope-intercept form is huge in 7th grade. It gets introduced for the first time, and then is used for the rest of mathematics. All right, so we need to find the slope, and we need to find the intercept. Well, hopefully we can find the intercept. Okay, when it says y equals mx plus b, this is your y-intercept. It's the y-intercept because if you make x 0, anything times 0 becomes 0. So when x is 0, then y equals b. And so that's why my y of 5 at x of 0. So you look to see where does the line cross the y-axis when x is 0. Well, it crosses at 5. Okay? So my y-intercept is going to be 5. So everyone should get this right. Slope takes a little bit of work, and there's a few different ways you can do it. So we can use the slope formula, right? And let's see what we have in our reference materials. All right, do we have the slope formula here? That is something that you probably have learned, but it's something that will be taught a little bit more formally in 8th grade, Algebra 1. You can look for the change in y over the change in x. So let me introduce that for you. You take two different y values and you subtract them. And then you take two different x values and you subtract them. Because the slope is always the change in y and the change in x. You could do it manually, but you need 2 points. I've got the 0, 5. You need points that seem like they cross an integer. So that looks like it's -1, 2. All right, so I'm going to take my two different y's, and I'm just going to pick these as my y sub 2's, or my y sub 1 and my y sub 2, as long as you match up x1 with y1, x2 with y2. All right, so I've got 5 minus 2 over, and then I've got negative, let's say I've got my 0 minus -1. 0 minus -1 makes +1. So that's really 3 over 1, which is just 3. All right, so my slope is 3. Another way to look at it, if you don't want to do that, is you can look, you need to start with 2 points here, and you want to go over 1 and see how far does it go up or down when it goes over 1. So it goes up 1, 2, 3 over 1. So there's your 3 over 1. We call that our rise over run. So you could just do it visually without necessarily doing all the math if you want to. So that is going to be 3. Now, we could have eliminated 2 of these because a negative slope comes down like this. A negative slope goes down from left to right. Okay, a positive slope goes up from left to right. So we could have gotten off of -3 and -2 because those are negative and we want a positive slope. Now we would have had to choose between +3 and +5. Now, here's where it gets interesting. Here's our answer. 2-point problem. We only had 11% of our students get both of these. 35% of our students get single credit. So if you put those together, you're looking at 29% overall correct. 54% of our students walked away with nothing, which means 54% of our students at least didn't get that. If we assumed that every single one of those 35% with 1 point got the y-intercept, that's still only 46% that nailed the y-intercept. So this is something to where 7th grade teachers, you definitely need to be looking ahead to see what they'll be doing in 8th grade in Algebra 1. And we can go and be introducing this if we're not doing it already. We can showing them how to do this, right? Both ways. But this is a skill that they will need the rest of their lives. This ended up being the 5th hardest item on the entire test because it looks like there's not enough information there. But as you can see, there was. 22, we are looking at the area of composite figures. And this one's pretty straightforward. You've just got like an inverted L. You got two rectangles, and I can cut this up multiple ways. And so this is 7.9c, and the key here is the additive property of area. If you take a big shape, cut it up into smaller pieces, as long as you're not missing anything and they're not overlapping, just add up the smaller pieces, and that's the area of the larger shape. Okay, so if I wanted to, I could do this right here. Draw that line. Now I've got two rectangles, okay? So I've got this one right here, and this one looks pretty simple. I've got my 8 times 6, that's 48. Now I need to figure out this side length right here. So this is 8 out of all the 13, which means that's going to be 5. And then this long side on the left is my 7 plus my 6, so that's my 13. So I still need to figure out what those two side lengths are. But I've got my 13 and my 5. 13 times 5 is going to be 65. So you add your 48 and 65, and you get 113. Now, you didn't have to set it up that way. We could have set it up this way. So let me show you this way. Okay, so this would have been 7 times 5, 35. So let me put this back over here. So 65 plus 48. I want you to see that no matter what you do, you're going to get the same answer. if we did black here, and then I've got this 13 times 6. So 13 times 6 is going to be 78. So 78 and 35, 113. Or you could have actually done it 3 different ways. All right, so you could have done this little guy up here. That would be a 6 times 5. That's a 30. And then this over here is still 35, so we can still use that. And then this right here is still 6 times 8, 48. Okay? And guess what? You're going to get 113. No matter how you do it, you're going to get 113. So that is our answer. And we did decent on that. This was kind of right in the middle of the road. 50% of our students got that correct. Now, our biggest distractor was C. And so how did we get 134? Well, we might have said the area of uh, the top rectangle, right? 6 times 13. There's your 78, right? So we got this right here. And then, so they knew that they needed this right here, but then they needed that bottom part, and then the only other two numbers were the 8 times 7. So they just took the four numbers they saw, 56. But as you can see, this 8 times 7 is actually a missing rectangle. So that's not what we needed. We needed them to find that 5, that missing 5, and do 7 times 5. So that's how they got 134. And so this was right in the middle of the pack. This was the 19th, or tied for 19th easiest and hardest, literally right in the middle of a 38 item test. And so this is an area that we can talk with kids to where if we're dealing with composite figures, make sure that the practice problems we're dealing with include these missing values that they have to calculate, because I think that's what threw some of them off. Number 23, we are looking at rational number operations. This is 7.3a. And this looks at it as about vanilla as we can get here. This looks like something we would say at the beginning of the test. Look at this. 0.35 minus 1/5. All we need to do is need to convert both into fractions or both into decimals. I always think let's change both into decimals because the fractions aren't going to work unless they're the same denominator. So let's change this into a decimal. I could divide up, but if we can just get our denominator to be 10, 100, or 1,000, that's going to work with my tenths, hundredths, or thousandths. 5 times 2 makes 10, so this is 2 tenths. Literally, this problem is 0.35 minus 0.2. Now we need to go ahead and line it up. And if you think that's way too easy, well, it is way too easy. And our students did fairly well on this, but only 63% of our students, let's see, 63%, not 65, got this correct. 15% chose B, 17 chose C, and I think you can see where we get the C. This is 0.35 minus 0.05. Like equating this with this is still problematic. That's not what we need to be doing here. And so this ended up being pretty easy. This was actually our fourth easiest. So I'm not sure whether we're excited about this or we're a little bit frustrated that only 63% of our students were able to get this. Either way, pretty easy. Number 24, we are looking at simple and compound probabilities. And this is 7.6i. And in this case, we got a deck of cards. Red, orange, yellow, and green. Each color, there are 10 cards labeled 0 through 9. Okay, so I have got 4 colors. Okay, so I'm just going to put them like this. I'm going to have 10 red, 10 orange, 10 yellow, 10 green. probability of randomly selecting a red card, replacing it, and then randomly selecting a card labeled 0. All right, let's look. This is a compound probability because I've got two simple probabilities. First, this one, how many reds, and then this one, a card labeled 0. All right, well, how many reds do I've got? Well, there's 40 cards, and 10 of them, the probability of getting a red is 10 out of 40, or let's make that 1/4. Okay, this is the probability of getting red. Now, let's look at my zeros. Think of it like an Uno deck, right? You've got 0 through 10. They don't have 0 through 10, they have 0 through 9, but close enough, right? You've got your four colors. So how many zeros are we going to find? Well, there's going to be a 0 in here, a 0 in here, a 0 in here, a 0 in here. So there's going to be 1, 2, 3, 4. So there's 4 zeros out of all 40 cards. And it's going to be 40 because we replaced the card. If we didn't replace this card, then our probability would have had a different denominator. And it would have messed up the second one because we would have had to know what that first one was. So this is going to be 1/10. Now, how do we solve for a compound probability? And so let's make sure we understand we're dealing with compound. Well, you multiply the two simple probabilities. So 1/4 times 1/10. So 1 out of 40. So if you were to do this exact thing 40 times, statistically, only once should you pull out a red, replace it, and then pull out a 0. So our answer is A, 1/40th. And we only had 33% of our students get that correct. We had 30% of our students choose B. So that was our big distractor. And so how did we get B? Well, students probably thought it was calculated slightly differently. So let me show you down here. If you think there's a 1 out of 40 chance, like maybe there's one red card, and then there's 1 0, like they just took the I want one card, I want one red out of 40 total cards. I want 1 0 out of 40 total cards. They added those up. You got 2/40ths, which then obviously reduces down to your 1/20th. But that thinking is wrong multiple ways because you don't just have one red, you have 10 reds. You don't just have 1 0, you've got 4 zeros. And so students that chose this definitely need a lot of extra work, not even on the compound side of you multiply the two simples, but just setting up a simple probability from just pure words like this. So sometimes we'll get a table, sometimes we'll get some type of visual, but our practice needs to be with probabilities with just words because reading these problem situations and turning them into fractions, sometimes that in itself is the challenge. This ended up being tied for our seventh hardest item on the test. For number 25, we're looking at inequalities on a number line. This is 7.10b. And we just have a simple inequality, but we need to graph this using the number line feature, something that we don't use very often on the STAAR test. And so let's take a look at it. First, let's deal with our inequality. We've got negative 6k plus 6 is less than negative 48, right? We need to solve this inequality. Let's first start by dealing with that plus 6. We are going to use the inverse operation. We're going to subtract 6 from both sides. And so we're going to get negative 6k is less than. Now, when I take negative 48 and then I subtract 6, subtract means going to left. I'm moving farther away from 0, so it's like adding the two. So when you have a negative and you're subtracting something, think of it like you're just adding those two. It's going to be negative 54. Now I need to divide by negative 6. And that is going to become k. Now, here's the tricky part. In 7th grade, we spent a lot of time focusing on what happens when we divide by a negative or multiply by a negative. The inequality actually flips. It becomes greater than, and then 54 divided by 6, right? The two negatives cancel out. That's just going to become 9. So k is going to be greater than 9. Now, if we want to just verify that, let's just take a number and let's just take 10. Let's say 10 is greater than 9. Let's stick 10 in here. So that's going to be negative 60 plus 6 is less than negative 48. So that's going to be negative 54 is less than negative 58. And moving on the negatives, negative 54 is farther away from 0 than negative 48, so that is good. If I were to change that to just 9, right, this would be negative 48 is less than negative 48. I can't do that. So that's why I can't include 9. I have to be anything greater than 9. Now, that was the easy part, so to speak. Now we've got to figure out how all these numbers work. Take a look at what's going on. So I've got these little dots here, okay? And then I've got to move it somewhere. So first, we're going to go k is greater than 9. Let's draw what I want it to be. I want it to be an open circle, and I want it to go this way. I want it to be open because I don't want it to include 9 because it's not greater than or equal to. Then I want it to shift to the right. So I am to this one or this one. Now there's no key to let me know which one is which, but we always choose a closed circle when we are including the number itself. So this is going to be greater than or equal to. So we're going to have to use this white circle to represent the open right there. So let's get this white circle. So you just click it and it shows up, right? That's the first point, is clicking the correct circle. This is a 2-point problem. The second part of the circle is moving it to the right spot. So we're going to move it all the way over here. We're going to get a right on 9. Now this is the correct answer, and that matches up. This was the most difficult item on the test. This was the number one hardest item on the test. 2-point problem. We only had 11% of our students get both points. Only 23% of our students get 1 point. So if you take that half credit and add it up there, you're looking at about 23% correct. 66% of our students walked away with 0 points. First off, we had to deal with what happens when you divide or multiply by a negative. We had to flip the inequality, so that's something that sometimes our students struggle with. But even if you could get that, all of this business right here is quite challenging. So this is one in which we probably need some extra practice, either using this problem with our students, getting onto Cambium, or just mimicking this with paper and pencil, because this definitely required a little bit of extra work. Number 26, we are looking at volume. This is 7.9a. I've got a rectangular pyramid, and I simply need to find the volume. Pretty straightforward. And if I don't remember, that's fine. We've got our reference materials. Let's look at volume here. Volume of a pyramid, 1/3 base times height. That big B is the area of the base. So volume equals 1/3 big B times height. All right, so 1/3 is just 1/3. What is the base? Well, it's a rectangular base. We need to find the volume of this rectangular base. That's simply length times width or base times height. So that's 15 times 4. So I'm just going to put it all in here. 15 times 4, that's my base. Boom. And then my height is not a slant height, it's the actual height there. That's just 9. All right, so I could do a few things here. So I'm going to go ahead and just take 1/3 of 15. That's just going to be 5. And then 9 times 4 is 36. All right, so that is going to equal 180, or 180 cubic centimeters. So our answer here is C. We had 53% of our students get this, and unsurprisingly, 21%, our highest chosen incorrect answer, chose D. And if you can't figure out why they chose D, what that is this is without the 1/3. They forgot this 1/3. They just did base times height like you would a prism, and they did 15 times 4 times 9. And so that's fairly simple mistake, and that we should be able to correct that with enough practice. This is our 14th easiest, or tied for our 14th easiest item on the test, so not too difficult. Number 27, as you can see, we've got a drag and drop here. This is calculating personal budget 7.13b. So we're getting into our personal financial literacy. And we've got Roberto with a monthly budget, and we need to answer some questions. Okay, so we have a total monthly income of 5,000, and all of these are given in percentages. So we're going to have to take a percent of 5,000 to figure this out. All right, so rent. Instead of doing all of them, let's just figure out what we're looking for. We're looking for rent, and then we're looking for insurance. Okay, so the rest we don't need. Now, I'm going to do insurance first because that's going to be easy because I want to take 10% of 5,000. So 10% is the same as 1/10, is the same as 0.1. If I multiply that by 5,000, right, what you end up doing is you end up just moving the decimal over 1, right? So that's going to be 500. All right, so $500 is spent on insurance, and blank 500, less than, exactly, more than. Well, that's going to be exactly. That was easy. All right, and we can kind of get an estimate to get that rent. We could double that 500 to, well, take a look at this. If we double the 500, that's going to be 1,000. And if we double the 10%, that's going to get us 20%. So 20% of the 5,000 is $1,000. And we're already at 1,000, and he's at 24%, which means he's going to have to do more than that. Now let's verify with 5,000, but you could also just kind of use that number sense to say, well, if I double the 10 to 20, that doubles my 500 to 1,000, and I need to get up to 24, which means I'm going to be over it. But to verify, we can just multiply by 0.24, 0, 0, 0, 10. Lots of zeros, 2 digits behind the decimal. Yeah, 1,200. So more than 1,000. So spends more than $1,000 on rent. All right, so this is a 2-point problem, and that's how we get both points. Now we had 43% of our students get both. We had 29%. We're not sure which one was more chosen correct or which one was more chosen incorrect, but 29% get 1 point. Take that half credit, you get 58% overall mastery, which makes this pretty easy. 8th easiest item on the test. You could use some number sense, but just understanding how to change the percent to a decimal and then multiplying by total to get these numbers is not too difficult. Number 28, we are writing equations and inequalities. This is 7.10a. And so we have a verbal description. We need to turn it into one of these equations we see down here. So let's take a look at our story problem here. The office employees and the employee offices and break room in an office building cover an area of 7,000 square feet. All right, so that looks like that's my total. If they're giving it to you like that, and you see how everything equals 7,000, okay? Each employee office takes up 125 square feet. So I've got 125 square feet. Each employee offices. How many employee offices do we have? Well, let's squeeze ahead to the punchline here. X is the number of employee offices. So there's 125 feet for each employee office. I don't know how many there are, so we're going to multiply that by X. And then the break room looks like it's the break room, constant. It's up to 750 square feet. Now, that up to means it just depends on how many employee offices we have. And so we are going to just say there's one break room, so I don't need any type of variable with that. So I'm going to take my 125, multiply it by the X number of employee offices, add my break room, and that needs to equal 7,000 for my total square feet of the office. And so that is going to be A. And we had 54% of our students get that correct, so that's not too bad. 19% chose B. They chose the wrong coefficient. They put the X with the 750 rather than the 125. And then we had 21. Now, they chose the 125x, but then they chose that wrong operation. And then 6% chose D because everything was wrong on D. But this was overall not super challenging for our students. This was the 28th or the 13th easiest item on the test. Number 29, we are looking at the circumference and area of circles, 7.9b. And we have the circumference of a circle is the base of a cylinder. Okay. And what measurement is the closest to the diameter of the cylinder? All right, so let's look at our cylinder here. All right, so the circumference, so I'm just going to do that right there. C equals 94.2, or approximately 90. Let's make these wavy. 94.2. And we don't really need the cylinder, right? We're really just looking at the circular base, but that's fine because we're looking for the diameter. Okay, well, what is the relationship between the circumference and the diameter? Well, for a circle, circumference equals pi times diameter, or 2 pi r, but let's do pi times diameter. So the circumference equals 94.2, which equals pi times diameter. All right. And our pi, our estimation is going to be 3.14. So we're going to say 94.2 is about 3.14 times d. We want to find what d is. Well, let's isolate the variable. Let's divide both sides by 3.14. All right, we are going to do long division. And let's go ahead and multiply both by 100. Let's get that decimal out of there. So I'm going to take 94.2, and I'm going to turn it into 99,420 because I'm just going to go 1, 2, 1, 2. You don't want a decimal in your divisor. So 314, I'm wondering if this goes in 3 times. That would be super easy if it did. Let's multiply by 3, see what happens. 12. That's going to be 4. Oh, that's easy. Look at that, 942. Now, we do need to bring in that extra 0, but 30. So it's about 30 feet in diameter. This was not challenging for students. 60% of our students got this correct. Now, we had 15 feet as an option. That's the radius. 17% of our students chose the radius. And then 14% chose 60. They actually thought that um, that 30 was the radius, so they doubled it to get up to the diameter. And so they just probably did the 2 pi r, and they just doubled it on accident. Either way, this was not that difficult. This was tied for the 5th easiest item on the test. Number 30, we are solving graphs. This is 7.6G. And so what do we have here? Bar graph showing the age of campers. I'm going to kind of squeeze this down so we can get our answer choices there. We don't have to scroll up and down. So 7.6G, when we see bar graphs, and we've been looking at bar graphs or something like bar graphs, picture graphs, all the way back from kindergarten. So at this point, we're going to have to be doing a lot of math with this. Okay, so we're looking for the part of the campers that were young adults, teens, or children. Well, let's put some numbers on here. So senior citizens, 50. Adults, 60. Young adults is between 0 and 10, that's 5. Teens between 20 and 30, 25. Children, 60. So young adults is 5. Teens is 25. Children is 60 over, so I want to make my fraction, over the total, right? Because we're looking for the part. So let's do 5 and 25 is 30 plus 60 is 90. And then 90 over 50 and 60 is 110. So add that 110 to my 90, and I've got 200. Now, I definitely need to simplify this. So you can say, let's just cut in half, right? We're going to get 45 over 100, which should make us think, hey, that's 45%. So I'm thinking it's C, but let me go ahead and simplify it all the way down. If I divide by fives, I'm going to get 9/20. Just want to make sure that that wasn't one of the fraction options, which it's not. So 45% is our answer, C. And this one was on the easier side. 53% of our students chose this, right? We just had 18% choose 90%. That 90 was the sum of the bars, but it's only 90% of the denominator was 100. It's not 100, it's 200. So this was on the easier side, 14th easiest, or tied for our 14th easiest. When we get into bar graphs in 7th grade, we should be very comfortable coming up with fractions, percents, doing these basic calculations. But that's basically all that they can do to try to challenge us. 31, we are looking at constant rates of change, 7.4. And so we've got this gray well. We've got all kinds of information about this gray well. So we need to find an equation that best represents K, the number of kilograms of food a gray whale eats in D days. Okay, so it eats 130,000 kilograms of food during a 130-day feast. So I'm looking for a unit rate. Well, that's my total divided by, what do I have there? Okay, so I've got 130, and so that's going to equal my unit rate. Okay, and so if I'm looking at this, I could just go ahead and, do long division like that, but I can also think, look at this. You see how the 130 kind of lines up with each other right there? Those are going to simplify to 1. 130 over 130 equals 1. And then I've got my 3 zeros left. So it's 1,000. You could divide 130 into 130,000. You would get 1,000. So that's going to be my unit rate. Okay. So then that's what I'm looking for right there. So K, the number of kilogram um, of gray whale eats in D days is going to be 1,000 per day. So that's my unit rate. So I need my 1,000 D. So my answer is A. And we had 47% of our students choose this, just a lot of zeros. And so that probably threw some of our students off. So we had a place value error here. If you're off by one place value, you get that 10,000. And then some people just might have thought this was literally the unit rate, and they just took this 130,000 and just went straight down there. So they weren't necessarily thinking of how I can find that unit rate because we had two different variables. But let's be thinking about unit rates in 7th grade. So this was 17th hardest, so it was on the harder side, but kind of middle of the road here. Number 32, we've got attributes of similarity. This is 7.5a. And we've got these two triangles formed by these intersecting lines. All right, so KLM, the order is correct. So KL are the first two. PL, so I'm going to draw this in red. So those two line up with each other. LM goes with LV, so LM goes with LV. And then my first and last, KM, goes with my first and last, TV. All right, so that coloring is going to be extremely helpful. All right, so I need to find a statement of similarity that is true about these two. All right, so KL over LM. So KL, so let's do colors here. KL over LM. All right, so I have a red over blue is equal to LV. Oh, that's going to be a problem. Over TL. Yeah, if we're going to do it, you need red over red, blue over blue, or you need the red and the blues to match up. But that's not going to work. Let's try ML, so that's blue, over MK, green, equals VL blue. Okay, could work. Over VP green. Okay, you see how we got our colors to match up here? Blue across from blue, green across from green. So this could work. Let's check the others. Angle K. All right, now we're just looking at angles. Angle K is congruent to angle V. All right. No, take a look at what we have here. Since these are similar triangles, you have to match up. So there's an angle here between the red and the blue is congruent to the red and the blue. You have an angle here between the red and the green that is congruent to the red and the green, and I'll do a different color down here between the blue and the green, between the blue and the green. So they say angle K, which is my black. Let's make this black here. Angle K is congruent to angle T, but not angle V. So that is incorrect. And then angle T, black, is congruent to angle M. Angle M is that purple. So those don't match up. So that's a lot of thinking. But we actually did better than you might guess. We had 57% of our students choose the correct answer of B. And we had 21% of our students choose A. So that's just a lot of letters, right? It's the reciprocal of the correct ratio. If you were to flip this, then you'd be good. And then we didn't get a lot of students choosing that. So this was on the easier side. This is our 10th easiest item on the test. For number 33, we are looking at equations and inequalities. This is 7.11a, and it's pretty simple. We need to find the solution here, and the only challenge here is that we've got two different sets of x's. We have 3x and we have a 2x, so we need to combine like terms, which is something that we can do because these are two that have an x next to it, right? So we have a coefficient and a variable. So I have 3x's, and if I have 2x's, that is going to equal 5x. And then I've got my plus 20 and my 50. So now it looks more like a normal equation. And so we just needed to combine the 3x's and the 2x's. So we can use the properties of equality. So I'm going to subtract 20 from each side. That's going to get me 5x equals 30. Now I'm going to divide by 5 because 5 divided by 5 is 1, which basically makes that go away. And then x equals 6. Now, before we just click on it, move on, let's go ahead and plug this back in to verify that we got it right. So 3 times 6 plus 2 times 6. So let's go back to the original equation, not our simplified combined equation. So 3 times 6 is 18. 2 times 6 is 12, equals 50. That's 30. 30 plus 20 equals 50. All right, so our answer here is 6. And we had 51% of our students get this correct. We had 13% choose B. Now, our most chosen incorrect answer was D, x equals 25. And so what ended up happening here was we had got down to 5x equals 30, which is, correct at that point. But then instead of dividing by 5, we divided both sides by 5, right? And for some reason, they thought that 5x minus 5 would cancel out, and that gets you that x equals 25. So that's the misconception right there. And so they got all the way there and then didn't realize that they needed to divide rather than multiply. So that is just going to take some extra practice and instruction. This is our 16th easiest, tied for our 16th easiest item on the test. So not too difficult, not too easy. Number 34, we are comparing numeric data. We've got two different dot plots here, and this is a 2-point problem. We've got drop downs for inline choice. This is 7.12a. All right, so if we look at, we've got team P, team R. All right, so the median is greater for, and then our two choices are team P and team R. How do I find the median from dot plot? Well, I literally need to find the middle dot. So if I count from the front end of team P, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, so if I've got 15, that's an odd number, so I can do 7, 1, and 7. I'll need that basically from either direction, that eighth dot. 1, 2, 3, 4, 5, 6, 7, 8. Or I can count from the back. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so my team P median is 3. And then team R, let's count how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Same thing. Let's look for the eighth one. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So count from both ways to make sure. All right, so the median for team R is 2. The median from team P is 3. Therefore, the median is greater for team P. All right, and now I need the blank is the same for both. The mode, the range, or the maximum. All right. So what is the mode from both? Well, the mode for both is the most chosen number. And the most chosen number is 3. So that looks like that's the most. Let's look at our range. Range is the highest minus the lowest. Now in team P, there's nothing on 5. So it's 4 minus 0, which equals 4. This one we do have a 5. So we got 5 minus 0 equals 5. So the range is different, and then the maximum is just the biggest number. 4 and 5, also different. So it is going to be the mode that is the same. All right, so that is number 34. We had only 39% of our students get 2 points. Now we had 42% of our students get 1 point. So if you take that half credit from 1 point, put it together with the 2 points, you get 60%, which is not horrible. In fact, this was our 5th easiest, or tied for our 5th easiest item on the test. But it's because we had so many get that 1 point. So when we're dealing with mode and the range and the maximum, that requires 3 different calculations. Maybe that was too much work for the students, or we're juggling a lot of vocabulary words here. Mean, mode, maximum, range. It just takes a lot of practice with data problems to know what these words mean. Number 35, we are looking at surface area. So I've got the net of a rectangular pyramid, and I'm looking for the total surface area. This is 7.9D. All right, so we can use the additive property of area. So I'm just going to find the area of the smaller shapes, add them together. That's going to be my total surface area. So let's start with what's easiest, our rectangle. So I've got a 7 by 15. So I'm going to multiply that. All right, so 105. This is 105. Then I've got 2 fat triangles and 2 skinny triangles. I'm going to find the area of each and then double it. And then that's going to get me both fat triangles and both skinny triangles. So let's add the 105 right here. All right, so this fat triangle, remember these are going to be 1/2 base times height. So it's going to be 1/2. My base is 15. My height is 10. All right, so I want to take a half of 10. You can use the commutative property, swap the order. Half of 10 is 5. So 5 times 15, that's 75. All right, so that's 75 and that's 75. So if I double that, that's going to give me 150. Then I can do the same thing here. 1/2 base times height. So that's 1/2. My base is 7. My height is 12. I want to take half of 12. Let's use the commutative property. I don't want to take half of 7. That's going to give me a decimal. Half of 12 is 6. 6 times 7 is 42. So this is also 42. Let's double that to 84. Now, we can add. I mean, I could have added 275s and 242s, but then that's just a lot of numbers to add. If I can do a little bit mentally to save some time, that's always good. And there we go. We have 339 square inches. So our answer is A, and we had 44%. Only 44% get this. Look at our answer distribution here. 21, 20, 14. So our answer distribution on our incorrect answers is pretty indicative of guessing. And then quite honestly, some of the 44% probably guessed as well, and they just guessed correctly. So this was our 15th hardest, and really we're just dealing with the area of a triangle and the area of a rectangle. Now, what some students might have done is they might have taken this area right here and thought and multiplied it by 4, because maybe they thought all 4 triangles were the same, or they could have done for this. But really, we're not dealing with any area formulas that are outlandish. It just takes quite a bit of calculation. Sometimes when we get to a problem this big, students just get a little bit tired. So we need to help them focus on their stamina. Number 36, we are looking at operational word problems. This is 7.3b. And we have a scout troop buying waterproof canvas to make a tent. All right, so they buy 11 and 3/4. I'm going to change this to 11.75 because I'm going to have to multiply because it costs 18.36 a yard. And then they receive a discount of 1/10 off the purchase amount. How much does it spend? Okay, so first let's figure out how much it costs without the discount. And then let's take the discount. Now, what this is going to be, this is going to be a 4 by 4, which you might not have done, but it follows the same rules as a 4 by 2. We're just going to keep putting extra zeros in there. Let's not worry about the decimals at this point. So 5 times 6 is 30. 7 times 6 is 42. That's 45. And that's going to be 10. That's 7. Get rid of those. Put a 0. 5 times 3 is 15. 7 times 3 is 21, 22. That's 5, and that's 3. Get rid of those. Now let's do 2 zeros and an 8. That's 40. That's 56, 60. 8, and then 6 is 14. 8 and 1 is 9. Now, 1, 2, 3 zeros, because I'm in that fourth spot right there. But I can just copy down 1175. All right, so that's, and if I wanted to do times 5 times 6 digits, I would just keep adding zeros. Let's add all of this up. When we take the 1/10, that's going to be a little bit easier to calculate. So that's going to be 0, that's 3, that's 17, 15, 11. All right, I got 1, 2, 3, 4 digits behind the decimal. 1, 2, 3, 4. All right, so it costs $215, 73 cents. Okay, before we get to our 10% off. Now, let's take our 10% and let's go ahead and look at how we do that. So this is 10%. So what I can do is you can move the decimal over 1, and that's 10%. So 2157 is 10%. So what we could do is we can take our 215.73. We're going to drop that last 0. We're going to subtract 2157, right? And that's going to get us 614.19 or $194.16. Now, that was a lot of work. There might have been a few other ways. Instead of subtracting the 10%, we could have multiplied by 0.9. That would have got us the same answer. Some of you might have taken 10% off. You could take your 10% off the 1836 before, and then you could have only done that one multiplication. There's a few different ways to do it. But that's our answer. And we had 49% of our students get this. We had 23% of our students choose B. Now, how did we get B? Well, if you chose B, you did your 11.75, and then you added your 1836. So that's your first mistake. You added rather than multiplying. So that's going to equal, let's bring it down here, this 30, 11, and then you subtracted that 10% of the 30% of the 30, 11. So it's like 301, and then you subtracted 301, and you got 2710. That's how you get this right here. So they knew how to take 10% off. They just added rather than multiply, and that was the mistake. This was definitely challenging and involved huge numbers, and we can't use a calculator in 7th grade. That comes in 8th grade, so we had to do this by hand. This ended up being our 18th hardest or most difficult item on the test. Number 37, we are converting units. This is a 2-point problem. We have some drag and drop here. This is 7.4e. All right, so the length of a football field is 120 yards. There's approximately 55 meters and 60 yards. All right, so we need to figure out how we can solve this proportion. Well, look at this. If I have 120 yards, they give me this 55 meters equals 60 yards. So I'm just going to set it up like this. X meters over 120 yards, which is what they have here, equals, let's get my 55 over 60. So we need that right there, 55 over 60, because they don't include the units, but we need to include the units to match them up. So then basically look at what we're doing. If we want to go from right to left, we multiply by 2. Hopefully you saw that relationship between 120 and 60. So let's just multiply by 2 going left, and that's going to get you your 110. And you notice that we could only have the fractions in the first one, and then we can only have the whole numbers in that second one. So that was a 2-point problem, and we had 36% of our students get both points. We had 30% get 1 point. And I'm wondering if some of the 1-pointers were just that 110 because they were able to see that you could double the 60 to get to 120, so you double the 55. So that makes sense. So it takes 15 half credit points, add it to the 36, and you're going to get your 51% correct. And so this was on the slightly easier side, tied for our 16th easiest item on the test. Our final question is number 38. We are solving rate problems, 7.4D. And we have a cashier that can scan 45 items in 8 minutes. When they say this, let's just put this into a ratio, 8 minutes. At this rate, how many minutes would it take the cashier to scan 36 items? Well, we've got a proportion. All right, so X minutes. All right, now I will say this. It should be less than 8 minutes because it takes 8 minutes to do 45, so it should be less to do 36, and all of these are less than 8, so we're good, but sometimes they'll give you one that's larger, and we can just eliminate this, okay? And so how we can do this is we can do a little bit of cross multiplication now. So 8 times 36 equals 45x. So we need to do 8 times 36 and then divide that by 45. That's going to be 48, 24, 28. So now I have 288 equals 45x. Divide both sides by 45. Not really excited about dividing 45 into 288, but that's what we have in front of us. So if I double 45, that's 90. So if I double that, that's 180. If I Add another 90, that's 270. That's going to be close. That's 6 sets. So that is going to be 270. That's going to be close. And then let's add this. Now, 45 times 2 is 90, so another 2 is going to be 180. So it just gets us not too horrible. 6.4.